Estimate the change in energy due to PV work for a reaction in aqueous solution that generates 0.50 moles of gas at ordinary conditions. Work due to expansion or compression of an object is called pressure volume work, or PV work. Using modern science convention, PV work is calculated by taking the negative of the integral of the external pressure with respect to volume. If the external pressure is constant, which is typically the case for reactions carried out in containers that are open to the atmosphere, then the formula simplifies to the negative of the external pressure times the change in volume. The external pressure is equal to the atmospheric pressure. Here's an illustration of the reaction that generates a gas at constant pressure. Imagine the reaction mixture as being in a container with a movable, frictionless piston, shown here in red. As the reaction generates a gas, it pushes the piston upward. If the pressure on the piston is constant and equal to the atmospheric pressure, then the work done by the system is essentially the same as the case where the container is open to the atmosphere. At this point, we should be able to eliminate two of the answer choices given. The production of gas leads to an increase in volume. Therefore, delta V must be positive. Since external pressure is always a positive number, the calculated work must be negative. Whenever a system expands against an external pressure, the system is doing work, which involves a loss of energy. By convention, in this case, work is assigned a negative value. Therefore, choices B and C are incorrect. Both of these are positive. We expect a negative value for W. Since the change in volume is essentially due to the formation of the gaseous product, we can say that the change in volume, delta V, is equal to the volume of the gas produced. Using the ideal gas equation, PV equals nRT, we can calculate the volume of the gas as moles of gas times RT over P, where R is the ideal gas constant, T is the temperature of the gas in Kelvin. The pressure of the gas is equal to the external pressure. Therefore, we can substitute P for external pressure and substitute the volume of the gas for the change in volume. We can calculate work as the negative of moles of gas times R times T. It's convenient to memorize the value of RT at 298 Kelvin. It's equal to 2.48 kilojoules per mole. Therefore, work is equal to the negative of the moles of gas produced, 0.50, times the value of RT at 298 Kelvin, which is 2.48 kilojoules per mole, and this will give us an answer of negative 1.2 kilojoules. The correct answer is A.